All right, guys, welcome to Unit 2. You're going to need Handout 5 for this lecture. That is in the Unit 2 folder in Blackboard, so you've got to get used to going to a new folder. So go ahead and grab that and a pencil, and we will get started with our topic, which is set classes. There's going to be a lot of vocabulary today and just kind of a lot of new stuff. So we're going to take it slow. We're only doing one piece this week, and we are going to really kind of hammer this new skill to make sure that you're comfortable with it. That piece we are doing is a song by Alban Berg, and you actually see the first 3 notes of that song on the top of your handout. The first thing we're going to talk about is a pitch class set, or PC set, and that is a set of specific pitch classes. Looking at that little snippet of Berg's score, then, you can see that I've labeled that PC set as 7TE. And that is simply from the pitch classes involved. We have C flat, which is E, G, which is PC7, and B flat, which is PC10. Now, 2 important things that you might have already seen. The first is that the pitch class set is ordered from smallest to largest PC and not the order of the actual notes. And the second thing is these funny looking brackets that enclose the PC set. PC sets are always notated in those kind of curled brackets. I promise that becomes important later on. Now, another new term is a set class. Set classes are a way of kind of relating PC sets to one another. A set class simply describes the intervallic content of a cluster of notes. So pitch class sets that are part of the same set class are then related to one another by either transposition or inversion. Now, that's a lot of words, and it'll become more apparent in the next couple of days exactly what that means. Now, set classes are labeled using what we call the prime form. And the prime form is essentially a representation that applies to all members of the same set class. Prime form always begins with the integer 0. And prime forms are, this is a phrase that you'll hear a lot, packed tightly toward the left. And that, again, will become more clear in about 5 minutes. But prime form always starts with 0. That's one of the most important things to know. So to find the set class or the prime form of a collection of notes, there's a very standardized process, and it's written here in this nice little box for you. I'm not going to kind of read out the steps just now. We're going to jump right to application. I think this is much easier to conceptualize when you're doing it in real time. So let's look at the second side of the handout. We are going to take that opening trichord, which was PC set 7, 10, and 11. And we're going to figure out what its prime form is by following the steps that are up here in this box. So step 1, we're going to plot the PC set on the clock face. You've seen me do this in videos and in class before. So I'm just going to put little kind of nodes on the clock face for the 3 pitch classes. Now, step 2, you're going to find the biggest gap or the widest interval between the pitch classes. This one is really easy to see. We have a big gap right there. It's the interval of 8 semitones, and it is very clear on the clock face that this is the biggest gap we have. So step 3, we're going to pick one pitch class that's on the edge of that gap. So I'm going to arbitrarily choose PC7. Now, step 3A tells us we are going to call that pitch class 0. So I'm going to label this then. I'm going to write a 0 over here. Now I'm going to move away from the gap. Since we're trying to get the smallest sort of interval, we are going to avoid the big gap. So I'm going to move away from the gap in this direction, and I'm going to count semitones as I go. So if 7 is 0, then we've got 1, 2. Since I have a node here, I'm going to label that 3 and label this one 4. Now, that gives me a result I'm going to put over here of 0, 3, 4. Since our gap, this thing right here, has 2 sides, we're going to go back and we're going to repeat the same process starting on the pitch class that's on the other side of the gap. So I'm going to erase this. And now I'm going to start on PC 11. And again, I am going to go away from the gap. So this becomes 0. We've got 1, and I'm going to keep counting, 2, 3, and 4. So our result going in that direction is 0, 1, 4. Now, since these set classes are telling us the intervallic content of the collection, you can expect that this last number, which tells you the widest interval, is going to be the same, no matter which way you go as you avoid that gap. Now, you'll notice that step 4 has a little kind of clause that we did not experience this time around. If there's more than one gap of the same size, you are then going to repeat steps 1 through 3 for the 2 pitches that are on the outside of that gap. Because of the construction of this particular set, we had one really big gap, and that was the only one we had to deal with. Now, step 5, out of all the results that you wrote down, so we have 034 and 014, you choose the one that has the lowest number after the 0. That's what we mean when we say packed most towards the left. You want the set class that has the lowest number after the 0, because every one of them is going to start with 0. It's who comes after that is important. So by judging our 2 options, then we have 034 and we have 014. 1 is smaller than 3. So the set class for this particular PC set of 7, 10, and 11 is 014. And notice that I wrote this set class in square brackets. Again, I said the curly brackets, I promised they would be important. Now they're important. That's how we distinguish between a PC set and a set class, in part is by the shape of the brackets. Okay, now one of the cool things about set classes is there is a very limited finite number of them. Since each set class sort of stands in for a whole bunch of PC sets, you don't have a ton of set class options. So for trichords, there are only 12 possible trichords, and you see them listed here. And then tetrachords, tetra meaning 4, so clusters of 4 notes, you only have 29 possible ones. Now, under no circumstances would I expect you to memorize these. The trichords, you might find that you just sort of memorize them because of abundance of use, but I would never expect you to memorize these for class, so please don't worry about that. But the reason I gave you this table is when you're doing your work, when you're doing your worksheets or analyzing a piece, if you come up with a trichord or a tetrachord that is not in this chart, then that means that you did something wrong along the way. More than likely, you just have the wrong form. So say that you did all of our work up here and you said, oh, okay, my set class is 034. And then you look down here and you found that there's no 034 on the chart. More than likely, you just have your set class backwards. So if you go in reverse and count down, you will find the correct set class, I would say 4 times out of 5. Okay, that was a lot of information. And we will spend time in class on this on Wednesday. Let's go ahead and do a little practice as a group. Now, you have tons of blank clock faces in your course pack. So I am going to actually sort of do this on 2 different pages. I'm going to have my clock face here and sort of toggle back and forth between that and our handout. So let's take this first PC set. We have 3, 5, 7, 11. You notice it's in curly brackets, so that tells us it's a PC set, and it is ordered from lowest to highest pitch class. So I'm going to go over here, and because I'm old and I might forget, I'm going to write it down first, and then I am going to plot it on this clock face. So we have 3, 5, 7, and E or 11. Now, what I would like us to do is I would like you to try this on your own and then come back and kind of compare your answers with me. One thing I will say before I send you off, though, is just by looking at this, let's find the biggest gap first. So I see 2 candidates. So I'm going to say, okay, I've got this one gap here, 1, 2, 3, 4. And then I've got this other one that looks pretty big over here. 1, 2, 3, 4. They are the same size. So this brings us back to the comment on the second half of step 4. If there is more than one gap of the same size, repeat the upper steps for the PCs bordering that gap as well. So you are going to be doing steps 1 through 3 a few extra times for this particular PC set. So let's go ahead, and I'm going to leave you to your own devices to work this out. So pause the video, work out your options and come up with an answer for a set class for this, and then double check it on the chart and see if it's on the chart, and then come back and we will see if we got the same answer. Okay, so I have the set class written in brackets down here towards the kind of bottom left of my clock face. I am going to go through this step by step. If you feel comfortable, then just kind of skip ahead. If you do want a step-by-step process of going through this, then hang around and we will do that together. Now, my first step then is to find the biggest gap. And we talked about how there are actually 2 that are the same size. So I'm going to choose this gap as my gap to avoid the first time, which means I'm going to be starting on either PC 3 or PC 11 to figure out my options. So I'm going to start on PC 3. That's just kind of arbitrary. And again, I'm going to move away from the gap. So 0, 1, 2, 3, 4, 5, 6, 7, and 8. So my first option then, I'm just going to write up here, 0, 2, 4, 8. Now, keeping with that same gap, I'm going to do the same thing, but this time I'm going to start on PC 11. So I'm going to call that 0. I'm going to go away from the gap and keep counting. So we've got 0, 1, 2, 3, 4, 5, 6, 7, 8. So that gives me 0, 4, 6, 8. Now, those are the 2 options that I get when I use that sort of PC 11 to PC 3 gap. But since we have 2 gaps of the same size, I am going to now do the same process around the other gap. So now my gap is going to be this one from PC 11 to PC 7. And again, I'm going to arbitrarily choose one of those PCs to start. So I'm going to start with PC 11. I'm going to move away from the gap and I'm going to count as I go. So PC11 becomes 0. And then 1, 2, 3, 4, 5, 6, 7, 8. So 0, 4, 6, 8, which interestingly is the same as one of the set class options we got moving from the other gap. All right, now our last choice is to start with PC7. We're going to call that 0. Moving away from the gap, we're going to go around. So 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 2, 4, 8. Okay, now let's look at our options. First off, if we are looking for the smallest integer next to the 0, we can eliminate both of these because 2 is smaller than 4. Now, if we then had, say we had 2 tetrachords that were 0, 2, 4, 8, and I don't know, 0, 2, 3, 5. Our next step then would be to eliminate the tetrachord who had the biggest third number. So we'd keep kind of doing the same process over and over. But I'm sure that you guys at this point have figured out that both of these tetrachord labels are 0, 2, 4, 8. They are the same. So our set class then, our prime form is 0, 2, 4, 8. But what does it mean when we have the same set class going in either direction? Some of you may have picked this up already. That feature is something that is specific to symmetrical set classes. So when you have a set class that has an axis of symmetry that can be sort of, if I stuck a mirror right where that red line is and reflected it back, we would get the same thing. Symmetrical set classes will do that. We'll have the, 2 different options that are the exact same. Just to double check myself then, I'm going to look on my handy chart. 0, 2, 4, 8 is in fact there. That doesn't mean I didn't screw something up. It just means that I didn't screw it up in a way that I got a set class that didn't exist. You could still get it wrong when you have something on the chart, just so we're clear. Okay, let's go with a diminished 7th chord. And actually, I'm going to call an audible here. And can we change this to a half diminished 7th chord? Humor me, please. And I'll tell you why, because the diminished 7th chord is also symmetrical, and you guys just did that. And you know that that's symmetrical because we spent a lot of time talking about it with the Bartok and the octatonicism. So let's do something that's not symmetrical. So any half diminished 7th chord. No matter what half diminished 7th chord you choose, because set classes reduce everything to one representative and all members of the same set class are related by transposition and inversion, no matter which half diminished 7th chord you choose, we're going to come up with the same answer. So I am going to choose the half diminished 7th chord that starts on the pitch A. You can choose that one and work through it that way, or you can choose another one just to see if we end up with the same answer, which we will. So go ahead and work that one out. Plot it on your clock face, work out your options, and come up with a final set class for that half diminished 7th chord. And we will regroup and chat in a couple minutes. Okay, so here is your set class for any half diminished 7th chord. I wrote down the A1. I gave you the PC set as well. And again, noticing that my PC set is ordered from smallest to smallest to largest PC integer and not taking the root into account at all. But again, if you want a little sort of step-by-step rundown, let's go ahead and do it. My first step is going to be finding the biggest gap. And this one only has one biggest gap, and that is right here. Now from there, I'm going to arbitrarily, let's say, start at PC3. I'm going to call that 0. And I'm going to go around the wheel. 1, 2, 3, 4, 5, 6, 7, 8. So we have 03, 6, 8 as our first option. Now I'm going to do the same thing starting on the other side of the gap. So I'm going to call PC7 0, 1, 2, 3, 4, 5, 6, 7, 8. 02, 5, 8. Since there's only one biggest gap, we only have 2 options. So we're looking for the one that is packed most tightly towards the left, also known as who has the smallest number next to the 0. And that means that we can eliminate 03 because 2 is smaller than 3. 0258 becomes our set class. And that means that 0258 is the set class for any and all half diminished 7th chords. To make sure that that is on our chart, and sure enough, 0258 exists as one of the 29 tetrachord set classes. So that is your introduction and rundown of set classes. We will continue working on this. In class on Wednesday, we are going to use the Berg as a good introduction to set classes and making them work in analysis. But like I said, we will kind of continue working on this all week. So you have some assignments that will be due, some worksheets that you can do to kind of continue practicing. You'll get lots of practice in the next few weeks. The sort of crux of Unit 2 is set theory and atonal works. So you'll get tons of practice with this in the next few days. So if it still feels muddy and weird, don't panic. I promise it will get better. All right, thanks guys. I'll see you on Wednesday.